Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. Today class we are going to discuss about machine learning. So machine learning, it is a branch of artificial intelligence where the computers learn from data and it gains the experience. So without explicitly program, it gives the outputs. So the new data will be learned with the algorithms. It uses the data-driven decision-making process. So it learns from an outcome and it improves the performance over the time. So each time the data will be trained. So the output will be predicted and then the same data will be used for training also. So it involves the developing algorithm that adapt for a new data and it identifies the pattern available in this data and make the predictions and decisions depending upon the application used. It's like a human machine learning learns from memorization, again information extraction and example based learnings. So these will be useful for identifying the patterns for getting the better results. So some of the examples, so Netflix recommended content based on the viewer data. So for example, if you view some movies or some sports activities, so based on that, the new videos and new things will be recommended from the Netflix. This is some of the example for the machine learning. So machine learning, so this is a subset of artificial intelligence. So first the artificial intelligence, look at this, this is an artificial intelligence. So it reflect or it mimic the human beings. So it uses the intelligent process that will mimic the human intelligence. So subset of this only will be a machine learning. So these algorithms learn from a data and predict the outputs. So it's subset of machine learning only neural nets, or we can say the neural network. So these computation models that will be interconnected with the artificial neurons. And then subset of this will be a deep learning. So this is the multi-layer hierarchical model that will be learns and predict the outputs. Look at this, the machine learning versus traditional software. So we are taking this different aspect. First in rule creation. So in traditional we use these rules for explicitly coded by the programmers. So the programmers based on programs set the rules for outputs. But machine learning, so rules are not given. So this is learned from data. So what the data we are giving for a training. So from the data it learns the rules. Dependence of the data, the code is a primary driver and data is secondary in the traditional softwares. But in machine learning, data is a primary driver and code defines the learning process. So in traditional, so only the code decides what is an output. So data only will be used as subset. But in machine learning, data is the primary thing that decides the outputs. So code is used to only use the data to training. So behavior over time, so traditional software is always static. So for example, if you give a one input today or after a few months or few days later, so every time it gives the same results. That's why it is called as a static. Okay, so only if you update the software, the results will be changed. Till that, the same output will be get from a traditional software. But machine learning is entirely different. This is a dynamic, so it evaluates with more data. So the based on the training increases, the output will be changes. So how much you are training, that much the data will be predicted will be very correct. So this will be based on the data trained. So we need to give a more data for accurate results. So this is a dynamic, that means so each time you give a data, new data, so it will be learns and improves its algorithm. So automatically the outputs each time it will be improved versions. Testing and debugging. So in traditional that should be very easy. So we can predict the outputs and easier to trace the errors because we are going to check the errors in our coding. But machine learning, this is entirely different. So output may be vary. So debugging focus on the data quality and models. So we cannot predict the mistakes in the codes. So here the debugging will be depends on the data. So for example, if accuracy is not expected level, that means the data given to train will be not sufficient or not relevant data. So that should be addressed and that should be solved. Development focus. So here we use this control flow, logic and algorithm in a traditional softwares. So that is, so we do have a set of rules and regulations and coding process. So that will be decides the control flow and logic and algorithms. In machine learning, so it will be processed with the data processing. So the data empathizes the results. So the model training and evolution, everything depend on the trained data. Example, we can see this is performance measures. So the correctness of output for all cases, the accuracy is generation and it depend on the data. And example use cases. So traditional softwares, we can take in some examples like in banking software, payroll systems. So machine learning, we can take in some examples like a disease prediction, image classification, and other things. Thank you.